Swayam Prabha. Digital India. Educated India.
So, we are discussing that synergistic environmental UV risk. So, we have discussed that at the environment UV and heat combined risk we have discussed, and in the marine environment different types of the risk we have discussed, like it is exposure enhanced by 25 to 30% by the reflection from the water, and in desert area we have discussed that the sun the sand reflects 15 to 20% UV incidence, and the main problem is it creates the multi-directional exposure which challenge the sun protection strategies. So, that is that we have already discussed. Now, so in addition to that, in sports UV exposure is very high. So, because athletes are most of the outdoor games are in the in front of under the sun. So, athletes like skiing basically in the particularly mountaineering skiing, in those cases that they are exposed the UV ray. So, along with their other other requirement in the clothing. So, UV protection is very important, and cycling is also important. So, in these types of clothing the main problem is that, or tennis. So, high active clothing, high active sports clothing, the main problem is that we cannot have a very compact structure like the oven structures, because oven structure if we use, then it will restrict the body movement. Okay. So, that we cannot use here, and at the same time if we use the knitted fabric main problem would be that that will change the pore size. So, that particular designing the fabric structure for high active sports, it is challenging, because if it the pore size increases during the stretch, if the pore size gets increases, that will allow the UV ray to come in and reduce the ultraviolet protective performance. So, tennis track face cumulative UV doses are there. Okay. So, this type of athletes that face cumulative UV doses. So, high altitude sports exceptionally increase UVB intensity by 10% in every 1000 meter elevation, that we have discussed. So, every 1000 meter elevation this type of high altitude sports, the UV exposure, UV threat from the UV it enhanced. So, what are the prevention strategies and different protection interventions? The behavioral modifications are important. So, we can change our activities, like we can change our behavior. Okay. So, we should seek the shade during the peak UV hour. What is the peak UV hour? 10 am to 4 pm. So, if you want to go out So, that type of shade we should create, and we should actually use in the shade, we should work under the shade during this time and limit recreational sun exposure. So, that changes we should bring within ourselves. So, we should not go for recreational activity during this time, and we should monitor daily UV index forecast. So, we should actually see the weather forecast where UV index will be there, and we should monitor. So, depending on our that UV index, that is actually given by different types of sources like EPA, NOAA, actually this type of different sources are there. So, depending on that we can go out or we can protect ourselves. Topical photo protection. So, that is another important aspect. So, that we can apply sunscreen, sunscreen before at least 30 plus SPF, sun protection factor. So, that type of sunscreen we can apply on our body before we move, at least 15 minutes before the exposure. So, that we can try to use and reapply after 2 hours and after water immersion. So, water immersion, as we have discussed, that particularly in saline water it gets washed away, and normal even after water application. So, that we can reapply again. So, different types of requirements are 2 milligram per square centimeter application. So, that type of density is required for labeled SPF efficiency. So, that we have to use this type of sun protective sunscreen lotion, and physical barrier is there. So, wide brimmed hats. So, hat we can use and with a wide brim. So, as it is shown in this picture. So, that the brim width should be more than 7.5 centimeter. So, that is as per the standard. UV blocker sunglasses we can use, and tightly woven fabric. So, the fabric structure, the protective clothing structure should be tightly woven, which provides superior protection compared to chemical sunscreen alone. So, chemical sunscreen we can use to those places where uncovered spaces only, like face and fingers, or all these places we can apply, but we can cover ourselves with the tightly woven protective garment, and sunglass we can use, and wide brim hats. So, these are the different types of physical blocker. Now, which actually is important, whether should we go for sunscreen or protective UV protective clothing. So, there are different types of roles are there. So, where to use the sunscreen and where to use the protective clothing, that is actually that. Let us see the comparative efficiencies. So, UPF rated garments offer consistent non degrading protection independent of user application. So, if you have a clothing of certain UPF rating, that will give the consistent protection irrespective of the time or duration, whatever whether we are using in for long time, okay, that will the degradation will not get protection will not get degraded like sun protection. Okay. So, unlike sunscreen, textiles provide mechanical UV blocking without chemical absorption or photo degradation concerns. So, that is important. Here in textile UV protective textile, we mechanically block the pores and which will block the UV ray to get penetrated through the textile material. Okay. So, here chemical applications are not there. And it can create the UPF more than 50. So, more than 50, the UPF rating is 50 plus. So, 50 plus 50 UPF rating means it is a more than 98% of UV radiation is blocked. So, 50 means only 22% of UV will pass through the clothing. So, which is equivalent to SPF 50 plus. So, UPF 50 plus is equivalent to SPF 50 plus. So, SPF 50 plus is supposed to be very high sun protection, but the main advantage with the UPF rating is for textile material, SPF rating is for sunscreen lotions, and the main advantage of textile protection, the garment UPF rating is that it is consistent, it does not change, it does not wash out. So, but in case of sunscreen lotion, we have to reapply and up to 8 hours duration. So, all day protection is there without reapplication requirement, that is very important. And the UPF clothing technologies, ultraviolet protection factor, that is UPF, quantifies the textile transmission blocking. So, how much UV ray is being blocked from transmission. Okay. So, which the fabric is engineered. What are the engineering aspects? So, if we weave the fabric in tight construction, so tight weave construction which will prevent the UV ray to pass through, which that minimizes the interstitial UV penetration. So, that is there, and also the fiber chemistry plays a role that we will discuss in details. Synthetic fiber like polyester, nylon, inherently they block the UV better than cotton. So, due to their structure, they block the UV ray. So, for UV protection we use polyester or nylon, but for comfort we prefer cotton. That there is a actually trade off. So, that optimization we have to make, whether we want UV to be protected, UV we should we need the UV protection or comfort. So, that type of optimization we have to do. So, UV absorbing additives can be used as we can incorporate as a nanoparticles within the structure fiber, or we can use as a coating. So, titanium dioxide, zinc oxide nanoparticles embedded in the fiber matrix. So, within the fiber during the spinning, that nanoparticles are incorporated within the fiber. So, fiber inherently becomes the UV absorbing. So, say polyester, we are by nature, by its chemistry, polyester is UV blocker, okay, by inherently it blocks. But if we incorporate nanoparticle during the spinning process, this nanoparticle will enhance the UV absorbing capacity. And also we can optimize the UV absorbing capacity of fabric by optimizing the dye depth. So, depth of dye or color selection, like darker color and specific chromophores enhance the absorption. So, light color will not absorb the UV ray. So, if we want to get better protection, so we must use the dark color. The clinical recommendations are there. So, UPF more than 30 garment for occupational settings, and UPF more than 50 for exposure to environments and photosensitive population. So, that the people who are very sensitive towards the UV ray, they must wear UPF 50 plus, okay, and people are at the high altitude. So, this type of cases they can wear, they can select the UPF of fabric UPF more than 50, but in other typical other different types of occupation they can use UPF of 30 plus. So, different types of clothings are available. Now, the fundamentals of UV textile interactions. What are the different types of fundamentals are there? We can see here. So, it is very important to understand the complex mechanism by which UV radiation interacts with textile materials. That is important. Then only we can design our clothing for protection. So, what we should do, whether do we need the transmission and or reflection, whether do we need the absorption or scattering, that is important, that we have to decide. So, depending on that we can this type of interaction with the textile material. So, depending on that we can design our clothing. From the foundation of UV protection engineering in modern fabric design. So, this actually this all these things, this forms the UV protection engineering. So, basically we have to design our clothing for, do we need to transmission, do you need to block the transmission, do we want to enhance the reflection. So, these things we have to consider, and this only forms the foundation of the UV protection in designing the clothing. So, what are the UV transmission and reflection mechanism that we must understand the UV transmission and reflection mechanisms before we start designing the clothing. So, UV transmission mechanism, let us understand. So, here you can see the UV radiation penetrates textile through 3 primary pathways. So, how this UV rays, suppose this is the our fabric. So, UV ray is coming say from sun or from different sources. Here there are 3 different ways it can pass through. So, direct transmission through the fiber volume. So, there are fibers are there. So, it can pass through the fiber. So, if we use the fiber like polyester, it can block, it can reduce the transmission. Or if we use the cotton, cotton does not absorb too much. So, that means it will pass through the cotton. So, through fiber volume it moves through, then transmission through the interfiber space. So, in a yarn there will be spaces. So, that in through interfiber space the UV ray passes through. If we try to have the higher blockage, so whether should we go for the low twisted yarn or high twisted yarn. So, for low twisted yarn the interfiber spaces are more. So, UV can pass through easily, but if we use the very high twisted yarn, so interfiber spaces will be less. So, it will block the UV. So, transmission through interfiber space and then transmission through the inter yarn gap in the fabric structure. So, these are the different yarns. So, if you are having open structure, lower fabric thread density, then the UV can pass through easily, and if you use a very compact fabric structure, higher thread density, in that case it will be blocked. So, if we suppose use polyester with very high UV absorption capacity. Now, let us try to show it. Okay. Now, polyester with very high UV absorption capacity and high twist will, where the interfiber space is less, it will enhance the UV protection, and third one is tight weave with high thread density. that will actually reduce the inter-ion gap and that will enhance the UV protection. So, we can design our fabric to enhance the to control the UV transmission mechanism. So, depending on we must select our yarn structure, we must select the fiber, what type of which fiber has to be used, what type of yarn structures should be there. So, everything is actually it controls the UV transmission mechanism. So, porosity, fiber diameter and fabric construction significantly influence the transmission rate. So, all these things we have discussed, even fiber diameter, if we change the fiber diameter, that will affect the yarn interfiber space, the yarn porosity of the yarn. So, that will also influence the transmission characteristics. Even fabric construction, even if it is a twill weave or satin weave or plain weave, keeping all other parameters constant, that will also affect the UV protection. And this is the UV transmission we can control through this. And now, how to get the reflection. So, that UV only we can block the UV by preventing it from the transmission. The transmission mechanism can be controlled by in the textile by all these parameters which we have discussed. Now, the reflection from the fabric layer, how to control this reflection? Surface reflection occurs when UV photons encounter the fabric interface and are redirected without penetration. So, that is important. It will not be actually it will not penetrate, it will get the reflected from the surface. So, which is done by the reflection efficiency depends on the fiber refractive index. So, we can use a certain fiber with high refractive index. Surface morphology. So, what will be the surface of the type of the surface of the fiber and the wavelength specific intersection. Which wavelength is coming, which wavelength of UV is coming on the fiber, and that interaction with the fiber is important. So, white and light colored fabrics typically exhibit higher reflectance. So, that will give higher reflectance if we use white colored or light colored fabric. So, what are the different types of UV absorption and scattering principles? In particularly for textile material. Now, the absorption is as we have mentioned that polyester and are good absorbent. So, chromophoric groups with polymer chain absorbs a photon, that is a very important aspect, and the converted it converts the radiant energy into heat through non-radiative decay. So, chromophoric groups within polymer that absorbs the photon, and that non-radiative decay will be there which converts into the energy. So, aromatic structure and conjugated systems enhance the absorption capacity across UVA and UVB spectra. So, for UVA and UVB whichever is coming. So, if we use the fiber or any polymer structure with aromatic structure and conjugated systems, that will enhance the capacity. So, this is the absorption, and scattering principle is the multiple scattering event occurs as the photon interacts with the fiber surface and internal structure irregularities. So, fiber surface and the internal structural irregularities, if it is there, that will scatter the UV ray. So, different scattering mechanisms are there, that depends on the Rayleigh's and my that scattering mechanism, that depends on the fiber diameter relative to wavelength, and which by increasing the effective path length through the fabric. So, these are the different types of scattering principles. Now, let us try to understand the UPF. What are the different, what is the ultraviolet protection factor, and this UPF is basically used for textile materials. So, the UPF, ultraviolet protection factor, which quantifies a fabric's effectiveness in blocking UV radiation, which is analogous to the SPF in the sunscreen. So, in sunscreen lotions, that is it's used for sun protection factor. Similarly, for fabric we use UPF value, and which denotes the blocking capability, okay, effectiveness in blocking of UV radiation. UPF represent the ratio of UV transmission through air versus the fabric, and it is measured in the full wavelength, the spectrum, it is a 290 to 400 nanometer, that is the which is affecting, that is a UV B and C. Full spectrum is used here. So, here if you see the ratio of the transmission through air versus through fabric. Now, if you see here, the UPF 50 indicates only 1/50th of incident UV radiation penetrates through the fabric. So, if the through the fabric, through the air, suppose X quantity is moving, okay, X quantity is moving through the air, but when we place a fabric, suppose this is a fabric is placed, here through fabric Y quantity is moving, okay. So, this only Y quantity is being penetrated. So, Y by X, this ratio is the UPF value. So, if it is 50 times, then we will call it as UPF value 50, and UPF 50 means, that means 98% is blocked, only 2% is passing through. So, this gives the excellent protection, okay, for prolonged outdoor exposure. So, UPF basically it is a ratio of incident light, incident UV ray which is incidented on the fabric and whatever is coming. So, y by x is the this ratio is the UPF value. So, 50 plus UPF is very good, excellent protection. So, which blocks 90% more than 90% UV radiation, and let us see the UPF rating scale and global standards. Now, UPF rating is 15 to 24 is supposed to be the good for normal exposure, moderate exposure, where typically 93 to 95, 96% typically around that type of 93.3 to 95.8% of UV radiation is being blocked, okay, and which is suitable for moderate sun exposure condition. So, a fabric with a labeled 15 to 24 UPF is a good protection, but not for extreme conditions. UPF 25 to 39 it is supposed to be very good, which blocks 96 to 97.4% of UV radiation, and here it is recommended for long extended outdoor activities in normal condition, and UPF 15 to 24 is for typically for short duration or moderate sun exposure, and UPF 40 and above is a excellent rating which blocks more than 97.5% of UV radiation, that is excellent. The maximum protection for high exposure environment, where the high threat from the UV ray is there. So, there it is recommended people should wear fabric with UPF more than 40, but if it is more than 50 then it is excellent UPF. So, there are different types of international testing standards are there. So, Australian and New Zealand standard AS and NZS 4399. So, here in Australian and New Zealand standards determine UPF measurement protocols and classification criteria. These are different types of protocols are there, and there are different classification, and European standard like EN 13758, this standard specifies the requirement of UV protective clothing and that it is a testing methodology. So, we have to follow one of these standards, and also ASTM standard, ASTM D6603. This is the American standard establishing the procedure for determining the UV transmission through fabrics. So, if we try to use this fabrics UPF rating, we should get tested by through international standard. So, what are the testing methodologies and what are the different types of equipments used? This we can see here. So, UV spectrophotometer basics. So, that using the UV spectrophotometer we can use to measure the UPF rating. So, the spectrophotometer measures the wavelength specific transmission by exposing fabric samples to moderate to a monochromatic UV radiation. So, we can use this one monochromatic UV radiation we can use, okay, and we can use measure the transmission. Okay. So, monochromatic UV radiation and which quantifies the transmitted intensity across the range of 290 to 400 nanometer range. So, that UV spectrophotometry we can use to measure the UPF, which measures the quantifies the transmitted exposure and also incident exposure. In vitro UPF testing is there in laboratory. So, laboratory instruments are available. So, laboratory assessment uses controlled artificial UV source. So, we can generate artificial UV source to actually irradiate conditions fabric spectrum the specimen. So, this artificial UV ray which is actually incidented on the fabric under standard condition, and we before we test the fabric is conditioned, and this detector, the detector is there which measures the transmitted UV and incidental UV. So, the detectors are there that incidence UV and transmitted UV it measures and calculate the UPF through standard algorithm, which is actually measures the ratio, and by calculating the ratio, and which accounts for solar spectral irradiation and erythema action spectrum. So, through certain procedure, it is a standard algorithm, we can use we can calculate the UPF. This is in vitro method, which is instrumental method, and third one is the in vivo method, where the human subject is there. So, there you can see the human subject trial determine the minimal erythema doses, actually that means minimal erythema doses are required to to create certain mark. So, MED to the on the protected versus unprotected skin. So, that minimum one is the unprotected skin and then protected skin through, though it is clinically relevant, in vivo testing presents ethical challenges, because we are using the human object and exhibits higher variability than instrumental method, because instrumental method is a standardized method, standard atmospheric condition we test even artificial UV sources we use, but here actual doses are there on the human, and depending on the human skin or the human physiological parameters it may changes. So, in vivo UPF testing is normally it is not done. So, in vitro testing UPF testing is done, or UV spectrophotometer also are used. So, the environmental factors are there, whether it is a wet or dry. So, in there are moisture, there may be moisture in the environment. So, clothing is there, normally most of the textile materials are porous, and moisture absorption reduces the air gap between the fiber. So, this is the and if the moisture particle, here the air gaps are there. So, if the moisture enters within the fibers structure, so it reduces the air gap and often decrease the UPF by 20 to 50%. So, a wet fabric has got the lower UPF than the dry fabric. Water's refractive index is 1.33, more closely matches the fibers refractive index, the enhancing the UV transmission through the reduced scattering. So, here if the water is present when the fabric is wet, so the scattering is reduced. So, when scattering is reduced, that means it will allow the UV ray to pass through. So, that is why, so UV resistance is low, UPF value reduces in case of wet fabric. A dry fabric, the UPF is high. So, elevated humidity exposure, high relative humidity causes the hygroscopic fiber swells and potentially increasing the fabric density, that is important. So, one is the fabric, when fabric is wet, the UPF is reduced, but on the other hand, for particularly for hygroscopic fiber, suppose this is the yarn structure. If the fibers are hygroscopic, the yarn will get swelled. So, in that case the space between the yarns will be blocked by swelling. So, high relative humidity causes the hygroscopic fiber swelling and potentially increase the fabric density will increase. So, there is a chance that UV will be blocked, but however moisture adsorption in the fiber surface typically dominates. So, but at the same time moisture presence, the water, through water the UV passes through easily. So, two things happens, one is the blockage, another is adsorption at the surface. So, the due to the blockage the UPF value may increase, but if the water is at the it adsorbed at the surface, fiber surface, typically it dominates, which decreases the overall protection performance. So, effectively at elevated humidity exposure the UPF value drops, although there is a little swelling happens, that too only for hygroscopic fiber. For non-hygroscopic fiber like polyester and all this, there with the increase in moisture the UPF value reduces. And next is that effect of stretching. So, during application when we are wearing, particularly for the knitted fabric. So, mechanical extension is there, then it will enhance the inter yarn space. So, during stretching, so this is the normal fabric, and if we apply the stretch during the wearing, mechanical stretch, inter yarn space will increase. So, that will enhance the transmission of the UV ray. So, reduce the UV attenuation, mechanical extension increases the inter yarn space and fabric porosity. That is why the in the UPF value reduces. So, stretch induced UPF loss can be as high as more than 30% okay, in elastomeric fabric under physiological strain level. So, for a sports person, if we use the knitted fabric as I have mentioned, so that will stretch and it will enhance the inter yarn space. So, that will reduce the UPF value. And the effect of sweating, the perspiration, like in case of weight we have discussed, similar reasons will be there. In addition to that, electrolytic and organic compounds are there coming. So, it gets wet and this introduces electrolytes and organic compounds along with the sweat that alters fabric's optical properties. So, this organic compounds and this electrolytes, the salt present in the sweat crystallizes, the salt crystallization may enhance the scattering, but overall wetting effect generally reduces the UPF. So, it gets wet, but soil, actually the crystallization of soil on the fabric surface, sometime it enhance the sunlight that UPF UV scattering, but at the same time it is actually wetting effect is there which dominates. So, in case of humidity exposure, the moisture adsorption was dominating, although there was a reduction in fabric pores, but here also in case of sweating, presence of salt basically it enhances the scattering, which is supposed to reduce the UPF, enhance the UPF, but presence of liquid, that overall wetting effect which is actually dominating, that effectively the UPF value reduces with the sweating. So, these are the environmental factors one should keep in mind before designing the clothing. So, we will continue with this UPF in the next session. Till then, thank you.